Welcome, Mr. Sutton here with the Pre-Cal Honors 8-4 Part 2 homework solutions on conversion and convergence of power series. On this problem, they want the first four terms and general term of a power series for this function, and then the interval of convergence. So we're going to start by getting the A1 value and the R value. Since this is in A1 over 1 minus R form, A1 is just your numerator, x in this case, and then R is going to be whatever is being subtracted from 1, so positive 2x, because that's what's being subtracted from 1 in this case. To write our function now, we're going to start with x. That's our first term because it's our A1, our first term of the series. So we can write f of x equals x. And now we're going to just keep multiplying by 2x, the common ratio, to get the rest of the terms. So our next term is going to be 2x squared. After that, we've got 4x cubed. And then our fourth term will be 8x to the fourth. And then dot, dot, dot. Now it's time for the general term. So let's figure out something that represents the rest of this. So I know that I'm multiplying by 2 most of the time, so I'm going to have a 2 in here, and I'm going to have a 2 to a certain power. I don't have a 2 in the first term, so that means I want 2 to the 0 power for my first n value, if I'm using 0 as my starting n value. So I'm going to write 2 to the n. Then if I plug 0 in for n as my first value, and I usually use 0, we get just 1 here instead of 2. Next, I need an x, and I'm going to do x to the n plus 1, because again, if n equals 0 is my starting n value, then I want x to the 0 plus 1 to be my very first term. And then plus dot, dot, dot to represent all the other infinite terms that are out there. Now for the interval of convergence, we're taking our common ratio, 2x, and setting its absolute value less than 1. So we can rewrite this as -1 less than 2x less than 1. And then if I just divide everything by 2, I've got -1/2 less than x less than 1/2. For this problem, I want the first four terms in general power term of a series that represents this function, and then the interval of convergence. Let's start by getting the A1 and the R values. For A1, I have whatever's in the numerator here, so 1 in this case. And for the R value, I have whatever's being subtracted from 1 in the denominator. So in this case, since we have a plus x minus 4 down here, that means that negative parentheses x minus 4 is our common ratio. All right, let's make our terms out of this now. So we're starting with 1. That's our very first term. So f of x equals 1 is the beginning of all this. And then we're going to keep multiplying by negative parentheses x minus 4 to get all the rest of the terms. So my next term, if I multiply this by 1, is just negative parentheses x minus 4. After that, I'm going to have a positive x minus 4 quantity squared. And after that, I have a negative x minus 4 to the third, plus dot, dot, dot. Now we have to do our general term. And I'm actually going to make this a plus, because plus would have been the next sign in the series here. So for my general term, since I am alternating back and forth between negative and positive, I have to have a -1 to some power to represent that. Since my first term is positive, and I usually use a starting n value of 0, I'm going to write parentheses -1 to the n power, because -1 to the 0 gives me a positive here. And then, as n goes up, it'll keep switching between negatives and positives. Next, I need an x minus 4 in there somewhere, but I don't have an x minus 4 in my starting term, so I'm going to make this x minus 4 parentheses all raised to the n power. That way, when I plug in 0 for my first n value, that'll just give me the 1 that I wanted here. And then I'll put a plus dot, dot, dot to give me the rest of it. All right, so now for the interval of convergence, we need the absolute value of our R value here, less than 1. And little trick, when you have a negative times everything inside an absolute value, you can get rid of that negative when you get rid of the absolute value and turn it into inequality form. So I'm going to write this as -1 less than, and now I'm just going to take the positive version of all this, x minus 4, all less than 1. And now to get x by itself, I just add 4 to all three sides. So we have 3 less than x less than 5. For this problem, we want the first four terms in general term of a power series to represent this function, and then the interval of convergence. So just like all these problems, we have to start by getting the A1 and the R value. This is essentially the infinite sum version of a geometric series. So we have an A1 value of 1, because that's what's in our numerator up here. For the R value, it's whatever is being subtracted from 1 in the denominator. Since we've got 1 plus 3x, that means the r value is negative 3x. So let's use this now to generate our series. So we have f of x equals our first term of 1, and then we're going to multiply by negative 3x for the next few terms. So we have a negative 3x plus 9x squared, and if we multiply by this again with negative 3x, we've got negative 27x cubed. Next, we need the general term. So I'm going to write a little plus dot 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 plus to show there's some terms in between here. And now for my general term, in order to get all of these terms, we're going back and forth between positives and negatives. So I'm going to put in a negative 1 raised to the n power. And by the way, I'm assuming my n value, my starting n value is going to be 0. I don't have to write that down anywhere, but this is going to work if you use an n value of 0. So negative 1 to the 0 would make that first term positive. Next, I notice that all these terms also have some version of 3 and an x in them. The 3, I don't want that to actually show up in my first term, so I'm going to make this 3 to the n. That way when I do 3 to the 0, I'm just going to end up with 1 still. And also I'm going to need an x to generate these terms. But again, I don't want the x in that first term, so I'm also going to make this x to the n. And then I'll put a plus dot 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 in the end to show this keeps going. So if you just want to test this out, if I plug in 0 for my first n value, raising all these to the 0 just gives me 1. For my next term, if I raise all these to the first power, I've got negative 3x, which is what this should be. If I raise these to the second power, this will be positive 1, this will be 9, this will be x squared. So you can see we generate all of these with this general term. Now for the interval of convergence, I'm going to take my r value, take the absolute value of that, and make that less than 1. And I'm going to use my little trick where when the whole thing inside absolute value is negative, I can take away the negative. So this is going to be negative 1 less than 3x less than 1. And then I can just divide everything by 3 to get negative 1/3 less than x less than 1/3. On this problem, I want the first 4 terms in general term of a power series for this function and the interval of convergence. So let me start by getting my a1 and r values so I can generate my series. a1 is just going to be whatever's in the numerator here, so that's 3. And then for r, it's whatever's being subtracted from 1 in the denominator, so that's just x cubed. So I'm going to write f of x equals first term is 3, and then multiply by x cubed to get all the subsequent terms. So 3x cubed plus 3x to the 6th plus 3x to the 9th plus dot dot dot. Now for that general term. We know our general term is going to need a 3 in it because all these have 3's. And then all we have in addition to that is just an x to some power. So I want to make this, let's see here, I can't make it x to the n. I have to make it x to the 3n in order to get these going by multiples of 3's. And then I'll do a plus dot 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 on the end to show that this keeps going. And now let me just double check. I'm assuming I have a starting n value of 0. If I do 3x to the 3 times 0, that's really just 3 times x to the 0, which is just 3. And then we have 3 times x to the 3 times 1, or 3x cubed, 3 times x to the 3 times 2, or 3x to the 6th. So this works with a starting value of 0 for n. All right, for the interval of convergence, I take my r value, x cubed, absolute value that, and make it less than 1. And then a little trick you can do here, when you have an x to some power and an absolute value, you can just do the root to undo that. So I'm just going to write this as the absolute value of x less than the cube root of 1. But wait a sec, what's the cube root of 1? It's also 1. Sweet. So now we're just going to make this negative 1 less than x less than 1 and call it a day. For this problem, I want the first 4 terms in general term of a power series to go with this function, and then the interval of convergence. Let me start by identifying the a1 and the r values. a1 is whatever's in the numerator here, so 1/4. For the r value, it's whatever's being subtracted from 1 in the denominator. Since we have 1 plus x minus 1, that means negative x minus 1, or negative parentheses x minus 1, I should say, is the r value for this. Now we're going to use these to generate our power series. So my first term we already found was 1/4, so I have f of x equals 1/4, and then some other stuff. Now I have to multiply by negative parentheses x minus 1 to get the rest of the terms. So our next term is going to be minus 1/4 parentheses x minus 1. And then I'll have plus 1/4 parentheses x minus 1 squared. And then minus 1/4 x minus 1 quantity cubed, and so on and so forth. Now for the general term, we know that we have to have, since these are alternating, we need a negative 1 to the n. And they also all have a 1/4 in them. So I'm going to write 1/4 and then negative 1 to the n. And it doesn't really matter what order you write these in. I also need an x minus 1 to the n power. And then a dot, dot, dot here to show that this keeps going. And let me just double check. I'm using a starting n value of 0. So if I have 1/4 times negative 1 to the 0 times x minus 1 to the 0, that's just going to be 1/4 times 1, or 1/4. And then if you plug 1 in, that'll be a negative, and we'll have the x minus 1 there. So this will work if you use a starting n value of 0. For the interval of convergence, I'm going to take all of this stuff for r, absolute value that, and make that less than 1. I'm going to use my little trick if I have a negative inside an absolute value, like a negative 1 inside an absolute value, and just make that positive. So I'm going to write negative 1 out here, less than just x minus 1, positive x minus 1, less than 1. So again, I'm just dropping that negative multiplier that was inside the absolute value. And now I can just add 1 everywhere here. So that'll be 0 less than x less than 2. For this problem, I want the first 4 terms and general term of a power series to represent this function, and then the interval of convergence. So I'm going to start with my a1 and my r values. a1 is whatever is in the numerator here, so 1/2. The r value is whatever is being subtracted from 1 in the denominator, so x minus 2 in this case. To get my first 4 terms, I'm going to start with my a1 value, so f of x equals just 1/2. And then I'm just going to keep multiplying by x over 2 because that's my common ratio. So for the next term, I've got 1/2 times x over 2, so that's going to be x over 4. Then I multiply this by x over 2, so that'll be x squared over 8, then x cubed over 16, plus dot, dot, dot. Now we need the general term. There's a 1/2 kind of hidden in all of these, and we're actually multiplying by 1/2 over and over again. This x over 2 is really 1/2 times x. So to get my general term, I definitely need a 1/2 to some power. What power? Well, I usually use n equals 0 as my starting n value when I'm writing general terms. You don't have to, but that's how I always do it. So if n equals 0 is the beginning n value, I'm going to make this 1/2 to the n plus 1. That way, if I plug in 0 for n like I always do for that first term, I'm going to end up with 1/2 to the 1 power. And that's going to give me 1/2. All right, now I also need an x. There's an x in most of these terms, not an x in the first one. So I'm going to want to do x to the 0 power to get that first term, which means I'm going to have to write this as x to the n. Because again, I'm using 0 as my starting n value. Even though I don't write that down anywhere, that's just what I always do. And you don't have to tell people what your starting value is, but it has to work consistently for some starting n value. So now I write this plus dot, dot, dot over here, and my interval of convergence, I'm going to let my r absolute value of that be less than 1. So I can rewrite this as negative 1 less than x over 2 less than positive 1. And to get x by itself, we just multiply by 2. So that's going to be negative 2 less than x less than 2. For this problem, they're telling us the Maclaurin series for 1 over 1 minus x is this stuff here. Which of the following is a power series expansion for x squared over 1 minus x squared? So on this one, if you haven't seen or encountered Maclaurin series yet, don't worry about that. That's a calculus concept, but you don't actually need to know anything about Maclaurin series to do this problem, because this is essentially a geometric setup here. We can think of this as a geometric series. We got basically the a1 up here, that's x squared, and then we have the r value down here is also x squared because it's being subtracted from 1. So if we have an a1 of x squared and an r of x squared, we can write out our series using that. So our series then, we're starting with x squared, and then to get each term after that, we just multiply by x squared. So we have x squared, x to the 4th, x to the 6th, x to the 8th, and so on and so forth. Which answer choice starts with x squared and has all pluses? Well, that's going to be, well, choice D has all the terms we're looking for. Choice B is kind of there, but we're not skipping the odd ones, so we should only have choice D for this one.